So we are Team Drop Table, and I'm Seth Weisman.
I'm Jackie Trahan.
I'm Connor Kanabi.
I'm Paul Stabula.
And we're going to tell you about our project, Somm. So the high-level overview of Somm is to recommend restaurants to users in the same fashion that Netflix recommends movies. And in doing so, we also want to provide analytics to businesses about their clientele from that same data set. And the driving design goal behind all of this is the idea that user interface should not be equivalent to user experience. So we don't want users pulling out their phones and opening the app and saying, I went to this restaurant at this time and I stayed for 30 minutes. You already have this computer in your pocket. Let's see how much data we can automatically track and then only require user input when deemed absolutely necessary.
So our architecture has three parts. We have the front end, the middleware, and the back end. The front end has the iPhone app itself that the users download, and then our web part is for business analytics. The middleware pretty much takes information from the iPhone app, takes the data, pushes to the recommendation engine, retrieves information, pushes back to the iPhone app, and does the same thing with the analytics for the web portal. The middleware is also in charge of saving and storing information to the back of the database.
All right, so we have chosen iOS to develop our application in. The reason being is we all have previous experience developing in iOS, and we also have found a long-distance GPS change API that tracks to see if you made a long-distance GPS change. So the application will work where you will download the app, you'll sign up with an email and a password, you'll log in, and right when you log in there will be recommendations based on the most popular restaurants around your area. When you're running the application in the background, we will be collecting information about your GPS, where you're going, using that API that I talked about previously. So let's take an example. Let's say you're in class and then you move to Chipotle. So the API will recognize that you have made a long distance change, and it will send your GPS information to the middleware server. So once it gets to the middleware server, then we will check to see if it is indeed a valid restaurant or if it's just information that we're going to throw off. We are going to develop the application using Swift, and the reason being is Swift is a brand new language just released at WWDC by Apple, and we want to be on the cutting edge of software. So if we decide to work on this application after the semester's over, we want to have a supported language that's new and quick and fast. There's also a new functionality in Swift which is called Playgrounds, and that's where you can actually see a live version of the application as you're developing it.
So the middleware will take information from the GPS coordinates from the iPhone, from all the restaurants, and say, hey, this is not a restaurant, and it will only let in coordinates for restaurants itself. We'll pass to the recommendation engine, and then it will receive recommendations from that engine and pass it back to the iPhone, which will show the user the recommendations. It will also take in the business analytics it stores and use chart.js to process that into some type of graph, so business users can log in and see what this app is doing for them. On top of that, we handle hashes for logins, passwords, storing information to a database, making sure there's no redundancy in user logins and accounts. And this is all done through Laravel. And Laravel is a PHP framework that utilizes Model View Controller. It uses PHP 5.5, so it's the latest PHP version. On top of that, it uses Composer, which that's the dependency manager. So to set up new Laravel applications, it's like one command line and you're ready good to go. And it's great for big companies. So if we ever expand to multiple users or developers, it's easy to develop on, and it's also great for small projects with only 5 developers. It has database migration, so it pretty much syncs. If there's ever a change, you have multiple development stations, it's easy for it to sync up. So there's never any issues with that. And it also has RESTful routing. So, and it uses simple closures to take responses and respond to any issues that come up or any responses from the server.
Right. And so our backend recommendation engine is going to be built on top of Apache Hadoop, which is a distributed file system meant for big data projects. And we have two reasons for using this. The first is that this is a growing and becoming a more and more important technology in industry and something we want to gain more experience with. And the second is we want to be prepared for the high influx of users when Tim Cook demos our app at WWDC this upcoming summer. So there's really two main functionalities that are meant to come out of this recommendation engine. The first, of course, the recommendations to our iPhone users. And so we're going to be doing that using a library called Apache Mahout, which is a machine learning library built on top of Hadoop. And so Apache Mahout takes in three things: users, items, and scores. And so our users are, of course, our iPhone app users. The items are the different restaurants that they frequent. And then the challenge for us is going to be taking our data set and turning those into scores that accurately represent how much or little they like different restaurants, so then we can come up with these different recommendations. The second is going to be taking that same data set and generating valuable analytics for the different restaurants. So were this to become a business someday, this is where we would see maybe businesses pay to see the analytics while users can just download the app. And so we can say things like, how often do your users come? Do you get the same users night after night, or do you have a high turnover? How often do they stay? What time do they normally pull out their phone and start thinking, I wonder where I'm going to eat tonight? And any other interesting questions we think we can answer from our data set.
So we did research on some of the major methodologies that are being used in the industry for software development, and we decided to go with agile methodology because of the flexibility. We're still students, we're learning, we're still kind of refining our requirements to make sure that they make our application be the best that it can be. And if even a new technology comes out next semester, we want to be able to adapt to use that if it can make our product the best. A sub-method we'll be using is prototyping, so we want to make sure that we have a functional product and then add additional features to make it better on top of that. Make sure that there's definitely going to be something that we can provide that is substantial and works. Another sub-method is cross-functional teamwork. We all have our specializations of what we're going to be focusing on tasks-wise, but we want to be able to help each other to get each step completed without letting it hold us back if just one area is not doing as well or running into some more errors. And then another sub-method that we'll be utilizing is Scrum. And so a big part of that would be our sprints. These are just major ideas within our sprints. We do have smaller subtasks underneath these. We have 7 sprints in total, and each sprint will be 2 weeks long. But even though they're 2-week-long sprints, we are planning on meeting at least weekly. Everyone in the team only has class on Tuesdays and Thursdays next semester, which leaves Mondays, Wednesdays, and Fridays open for long periods of time to program and discuss any issues that we might have. Throughout all of this, and especially noted in Sprint 6, is our testing, and we will be using the sub-method of test-driven development as well with that. Thank you for listening to us.